Okay, we will now be looking at finding n x-intercepts using the quadratic formula, a very powerful tool in mathematics. So first off, you will looking at identifying the a, b, and c value. So the a value here would be 4, is the coefficient of the second degree variable. The b value here would be negative 4. Remember, don't forget the negative, and then the c value would be 1. Now, the next step is to substitute into this formula here. So x equals, so instead of writing negative b, you'll write negative bracket, negative 4. Don't forget your bracket, plus, minus, and now your discriminant, negative 4 squared, negative 4, which is now the same negative 4, and then 4, and then 1 over 2 times 4. So here, I would recommend you calculate just maybe putting that. This is all over. The last thing you want to do is the division. So negative 4, you will have 4. Calculate your discriminant here. So your discriminant is going to be very interesting. You're going to have 16 minus 4 times 4 times 1, 16 over 8. So that means that your discriminant will actually end up being 0. So in that case, that means you only have one x-intercept, 4 over 8. So you're, or 1/2. That means you only have one x-intercept. That means your vertex would be found directly on the x-intercept. Very interesting example, which would be 1/2, 0 would be your x-intercept and your vertex at the same time. Now let's take a look at the second example, which would yield uh, eh, two okay, so the first thing is again to locate, to identify your A, B, and C variable values. So A here would be 6, B would be negative 7, and then finally C would be negative 3. Now the next step is to substitute into your formula. So here you would have negative 7, which would give me positive 7. Plus minus, so it means you're going to have to do it with once and for plus and once for negative once you've calculated the expression inside the root. So negative 7 squared 49, we'll get to that later, and then the negative 4, which always is there, and then 6, your a value, and then negative 3 over, all this is over 2 times 6. So the next line would look like this. You would have the 7, positive 7, because two negatives make a positive, plus minus, and then inside here you would have 49 plus. Where does the plus come from? Well, it comes from when you have the negative 4 and the negative 3, that gives me 12, and then the 6 times the 12, which is 72, comes from that. So it's over 12. Now, this expression here works out to 50 plus 72 is 100 and, well, let's start. We're going to use a calculator for this one here. So let's just put that inside my discriminant. So the second function, square root of, say, 49 plus 72, we could do it that way. So that the square root of that is 11. Oh yeah, because it works out to be 121. So that means that'll have 7 plus minus 11 over 12. So I'm going to do this once for a positive and once for a negative. So my first root would be 7 plus 11 over 12, which would be, you could do 11 plus 7, which is 18 over 12, which would be 1.5. So my first root would be 1.5. My second root is x equals 7 minus 11 divided by 12. So that's, you could do 7 minus 11 divided by 12, which would give me a third, negative a third. So x equals negative 1/3. And those are my two roots. That's how you use the quadratic formula.